Hi everyone, and welcome back to the Constructive Studies Foundation Detail series. In this video we'll be looking at the passive standard timber frame foundation, a highly efficient foundation detail designed to meet passive house energy standards while supporting a timber frame wall structure. As always, I'll explain what it is, when it's used, the main advantages and disadvantages, and I'll show you how to draw it step by step using an animated PowerPoint. Our learning intention for this video is to describe and draw a passive standard timber frame foundation showing all main components clearly and accurately to scale. Our success criteria are to be able to identify the key layers of a passive timber frame foundation, explain how it prevents heat loss and moisture problems, and produce a clear, accurate 1 to 10 drawing of the detail. We are also going to compare the passive standard timber frame to the concrete passive standard. A passive standard timber frame foundation is a modern, high-efficient version of a standard timber frame foundation. It combines continuous insulation, airtight detailing, and thermal break materials to reduce heat loss and prevent thermal bridging, the main goal of a passive house construction. In this design, insulation is placed beneath and around the floor slab and along the foundation wall and sole plate of the timber frame, creating a complete thermal envelope from the ground up. Special airtight membranes and vapor control layers are also used to keep the structure dry and energy efficient. One main advantage of a passive timber frame foundation is that it is lightweight, highly insulated and quick to construct, while still achieving very low U values and excellent airtightness. A disadvantage, however, is that it requires very careful detailing and installation to maintain continuous insulation and prevent air leaks. Now, let's compare it briefly to the passive standard concrete foundation. Both systems aim to minimize heat loss and improve airtightness, but they do so in slightly different ways. The passive concrete foundation has high thermal mass, meaning it absorbs and slowly releases heat, helping to keep indoor temperature stable. The passive standard timber frame foundation, on the other hand, has low thermal mass, so it heats up and cools down quickly, but offers excellent insulation and a much faster build time. So when would you use a passive standard timber frame foundation? It's typically chosen for timber frame passive houses where achieving ultra low energy performance, airtightness and rapid construction are key priorities. Just bear in mind when you're drawing this detail, divide all dimensions by 10. There are quite a lot of details in this drawing, so what we're going to do in this PowerPoint is really break it down step by step. The first thing you're going to draw is your reinforced concrete foundation, and this is measured in at 1260 by 420. The next thing we're going to do is we're going to start drawing our external leaf and our internal leaf. You're going to see that in the foundation we've got 3 vertical blocks, and then on the right hand side we're going to start off with 1, 2, 3, 4, 5 horizontal blocks, and then followed with 1, 2, 3 insulated lightweight blocks. Followed which we're going to have our concrete infill, and on the left side we're going to draw in our ground, and on the right side we're going to draw in our hardcore. You can see that it is 150 hardcore. On top of the hardcore we have got our 40 blinding. On top of the blinding we have our 150 concrete subfloor. On the right hand side here we have got our insulation, which is measured at 80 millimeters. And beside that we have got our insulation then, which is measured in at 150. And on top of that then we have got our 75 screed. On the left side here we have started our external leaf here, and this is going to be our traditional concrete block outer leaf. Next, what we're going to do is we're going to put in our 50 millimeters of wood fibre board, and we're going to start this off by drawing it at the top of our second insulated block here. We can see that we also have our breather membrane just here as well. On top of this insulated block we have got our sole plate and our bottom rail. On top of our bottom rail we have our 150 by 50 insulated joist, and on the right side here you can see that we have our 550 vapor check. Beside that then we have got our 50 insulation, and then on the left side here we have our 18 millimeters of render, and then on the right side here we have got our 12 millimeters of render as well. On top of our 75 screed we have got our 25 flooring. Once all that's done, we'll notice now that we put in our damp-proof membrane, our DPM, or our radon barrier, which we know prevents radon gases from penetrating up into the dwelling. You'll notice here that we have our air tightness seal, along with our anchor strap attached to the wall, and we also have our damp-proof course, or our DPC, which prevents capillary action. We also up here have our wall tie. Once you have all of those small details in, it's then just a case of ensuring that you label everything associated with the passive standard timber frame foundation. Once that's complete, this is how your drawing should look on an A3 page. You'll notice that we have the foundation in the center of the page, and there is quite a lot of detail in this drawing. Be sure to annotate your drawings. Make sure to point the arrows in where they need to be. And then there are a couple of keywords that you can place then in the right hand side. Before we wrap up, let's do a recap. Our learning intention was to describe and draw a passive standard timber frame foundation, and our success criteria were to identify the main components, explain how it reduces heat loss, and draw it accurately to scale 1 to 10. We also identified an advantage, a disadvantage, and compared it to our passive standard concrete block. We learned that passive standard timber frame foundations use continuous insulation and airtight detailing to prevent heat loss, and that compared to a passive concrete foundation, they're lighter, faster to build, and very well insulated, but lack the thermal mass that concrete provides. Thank you very much for watching, and I'll see you in the next video. Take care. Bye bye.